Circle, and today we're doing Senior Intermediate Session 2, which is a continuation on algebra. Before you continue watching, make sure to subscribe and like. Today we're going to be covering ratios, distribution, quadratics, and exponents and radicals. Our first topic of today is going to be ratios. What is a ratio? A ratio is a comparison. We can write this as a fraction, or we can use two or more numbers with a colon separating them. So when do we use them? So colleges use them for student-to-teacher ratio, or cooks use them for a recipe. So now we're going to move on to proportions. What's a proportion? A proportion is two ratios set equal to each other. There actually can even be more than two. So I have an example here for a ratio. We have 6 blue dots, and each dot represents one boy, and 8 pink dots, which each pink dot represents one girl. So there's 6 and 8, and they're asking for the ratio of girls to boys. Since they're asking for the girls to boys, not boys to girls, we want to write the number of girls first. So there are 8 girls, so we're going to write 8 to 6. But we can simplify this, because technically it can be written as 8 over 6. So which can be simplified to 4 over 3, which is our answer. So now let's practice using a proportion. So we have 3 nines equals 5 over n, and we're trying to find what n equals. So our first thought should be cross multiply. So when we cross multiply, we're going to take the numerator of one and the denominator of another, multiply them, and take the numerator of the other with the denominator of the first one and multiply those together. So technically, it's like a cross. So doing this, we get 3m is equal to 5 times 9. So 3m equals 45, since 9 times 5 is 45. And then we're going to divide both sides by 3 to figure out what n is. So n is 15. But how do we know if it's right for sure? We are going to check it. So 3 nines is equal to 5 over 15. And we know that's true because 3 nines can be simplified to 1/3, and so can 5 15ths. And for practice, I want you guys to do the following proportion. 6 over y minus 3 is equal to 2 over 7. Now there are two types of proportions. There's directly and inversely. So let's start with directly. So if we were to have the ratio x to y, then we either divide everything by the same number or multiply everything by the same number. As in, if one increases, so does the other. And if one decreases, so does the other. So now inversely. There's a set product. So if we were to have our two numbers, x and y, we can have ax to ya. When you multiply, then a's cancel out. So you still have xy. As in, if one increases, the other decreases. And if one decreases, the other increases. So a real life example for directly proportional is the more stuff you buy, the cost goes up. So more stuff, cost goes up. They're both going up. And the less stuff you buy, the less expensive it is. So both goes down. And for inversely, let's say you're going up a mountain or a hill. As altitude increases, temperature decreases. And as altitude decreases, temperature increases. So that's inversely proportional. We're going to move on to percent. Percent is a type of ratio which is part to whole. The whole is 100%. For example, if we were to have 25% of my beautiful drawing of a pizza, that'd be one slice out of these 4 slices. And its ratio can be written as 25 over 100, because technically each of these can be split up into 25 little parts. And I'm not going to draw because it's going to take too much time to give us 100 pieces. And each one would be 25. So technically this is 25 over 100. And so there are two things that we use for percents mainly, which is percent increase and percent decrease. This is when we start off with something and go to another thing, and we want to see by how much percent has it changed. If we're doing a percent increase, we're going to start with a new value, subtract the old value, and divide it by the old value. If we want to find how much percent it's decreased by, we're going to start off with the old value, subtract the new value from it, and then divide again by the new value. Our next topic is going to be distribution. Distribution lets us multiply a sum by another number by individually multiplying that number by its addends. For example, if we were to have three numbers, A, B, and C, and we were to multiply A times the sum of B and C, we would individually get AB plus AC. An example of this would be 5 times x plus 3. When we distribute, we take this number and multiply it first by that number and then by that, giving us 5x plus 5 times 3 is 15. So that's our answer for that one. So another rule, this is called the difference of squares. If we were to have our two numbers a and b, first multiply a plus b times a minus b, we would get a squared minus b squared, which is technically difference of two squares. So an example of this, let's start off pretty simple. We have 3 plus 2 times 3 minus 2. So plugging them in, 3 squared is 9, 9 minus b squared, which b is 2, 2 squared is 4, 9 minus 4 is 5. And technically, to prove it, what we can do is 3 plus 2 is 5. 5 times 3 minus 2, which is 1, is also equal to 5. So our last one is going to be a plus b times a plus b. It's the square of a sum. And the formula states that we get a squared plus 2ab plus b squared. It's really important to memorize that and the difference of squares. Those are basics that you must know. So another example of 3 plus 2. Let's start off with how to do it normally. 3 plus 2 times 3 plus 2. They're both 5. 5 squared is 25. And how to use it with the formula. 3 squared is 9. A times b, 3 times 2 is 6, times 2 is 12. And then 2 squared is 4. So 9 plus 12 plus 4 is 25. Our next topic is going to be on quadratics. A quadratic is a trinomial in the form of ax squared plus bx plus c. And the main thing we do with them is factor. And to factor is to write this quadratic in a product of two things, x minus a or x plus a times x plus b. That's the main form. So the way we factor is, let's take our example, x squared minus 6x plus 8. We use a diamond problem. For now, we would use a diamond problem, but later on, as you get more practice with factoring, you can easily do it in your head. So what we're going to do is we're going to start off with this diamond problem. So this is the form with AB on the top and A plus B on the bottom. A plus B is technically going to be B, and AB is C. So we have to find two numbers that have a product of AB and a sum of A plus B. So let's try doing it with our example. Our product is going to be 8, our sum is going to be negative 6. So the thing with our products and sum is if the product is negative, then there's going to be one positive and AB and one negative AB. And if it's positive, we're going to have either two negatives or two positives. And if our sum is negative, that means we're going to have two negatives. If it's positive, we're going to have two positives. So we do 8 and negative 6. 8 is positive, so it's either going to be negative negative or positive positive. And we look at negative 6. Then we know it's going to be a negative and a negative. So we're going to start off by listing our factors of 8. 1, 2, 4, and 8. And would you look at that? 2 and 4, their sum is 6. So we have negative 4 and negative 2. So we just put them in to get x minus 4 times x minus 2. And when you multiply it out, you get this. So what if we have a problem like x squared minus 6x minus 8 equals 0? And we're asked to solve for x. We can't just simply add 8 to both sides, divide by x. That's just too complicated. and it doesn't work. So what we do to solve a quadratic is we use one of two ways. There's a quadratic formula and there's zero product property. Zero product property is more common and much easier to do. So we start off with factoring that. But previously we factored this and got x minus 4 times x minus 2 equals 0. So whenever we have a 0 as the product, we know either 1 or both are going to equal 0. You can't just have neither of them equal to 0. It doesn't work like that. So we're going to set them both equal to 0. You have x minus 4 equals 0, and then you add 4 to both sides to get x equals 4. And then you have x minus 2 equals 0. And then you add 2 to both sides to get x minus 2. So x is 4 and 2. That's our answer. Another way to do it is if we can't factor it, there's a lot more math involved and it's easier to make a mistake. So that's why we don't use this as often. It's a quadratic formula, and it states for ax squared plus bx plus c equals 0, x is going to equal negative b plus or minus, remember that, the square root of b squared minus 4ac all over 2a. Our last topic of today is going to be exponents and radicals. We're going to start off with exponents. What is an exponent? An exponent is notation for repeated multiplication, and multiplication is repeated addition. So know the difference. An exponent has a base and the exponent. For example, in 4 to the third, or 4 cubed, 4 is the base and 3 is the exponent. And this basically represents 4 times 4 times 4. 3 4s. We're now going to go on to the exponent laws. It's really important to remember all of these because whenever you're simplifying something, you're going to use them a lot. So we're going to start off with if a to the x equals a to the y, then x equals y. A to the x times a to the y, that simplifies to a to the x plus y. A to the x over a to the y simplifies to a to the x minus y. A to the negative x, you flip it over to get 1 over a positive a to the x. And then a to the x to the whole power of y, you just multiply the exponents to get a to the x y. Ax times bx, different bases, same exponent, is ab to the whole power of x. A to the x over y is the radical with y and with a to the x in it. And this number 7 is how you're mainly going to convert from exponent to radical. A to the 0 is 1, a to the 1 is a, and 1 to the x is a, 1. Now we're going to move on to radicals. The main radicals we'll usually use are the square root of something or the cube root of something, or occasionally the y root of something. By that I just mean like the 4th root of something or the 5th or so on, just using y as a placeholder. So when we use the square root of something, for example, if there's nothing here, that usually means there's a 2. We just don't tend to write the 2 because we use it so much. So if we were trying to find the square root of 49, we're going to try to find what two numbers that are equal when they're multiplied together equal 49, and it's 7. And for the cube root, we can do the cube root of 8. And this time we're trying to find 3 numbers that are equal that when multiplied equal 8. In this case, it's going to be 2. Now some rules for simplifying radicals are the following. If you have the nth root of a times b, you can split it up into the nth root of a and the nth root of b. And the same goes for division. In this case, instead, it's just going to be a fraction. So the nth root of a over the nth root of b. And this one I wrote very big because it's really important with exponents. The nth root of a to the m is equal to a to the m over n. Really important to remember that when you're dealing with both exponents and radicals. And that's it for today. Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!